solve the differential equation by using separation of variable, dy by dx equal to y tan x, y equal to 1 when x equal to 0. To solve this equation, you write use separation of variable only, dy by y equal to tan x dx. Next step, you integrate. This is log y equal to log sec x, and for better calculation I am taking log c as the integration constant. This can be taken. Log c stands for integration constant. So log y equal to log c into sec x. Therefore, y equal to c divided by cos x. Okay. Now, is this condition when x equal to 0, y equal to 1? So c equal to 1 into cos 0. Cos 0 is 1 only. So c equal to 1. Therefore, required solution is y equal to y equal to sec x. Okay. Let us solve this one from textbook only. For the differential equation, x into dy by dx equal to x plus 2 y plus 2. Find the solution curve passing through 1 minus 1. Is passing through 1 minus 1 means we restate the sum when x equal to 1, y equal to minus 1. So solution you can do this manner: y dy by y plus 2 equal to x plus 2 dx by x. So this implies y plus 2 minus 2 by 1 plus 2 by x dx. Therefore, dy minus 2 dx by x. So this implies that y minus 2 log mod y plus 2 x plus 2 log mod x plus c. Now is the condition given there? When x equal to 1, y equal to minus 1. Two log 1 will be 0. So c is equal to minus 2. Okay. C is equal to minus 2, you substitute there. So therefore, y minus x is equal to 2 log this minus 2 is the answer. So when a point is given this manner, it passing through 1 comma minus 1, it means the condition is when x equal to 1, y is going to be equal to minus 1. Based on it, some calculation may be there. Then we'll do find the equation of a curve passing through the point 0 minus 2. Given that at any point xy on the curve, the product of slope of its tangent and y coordinate of the point is equal to the x coordinate of the point. Again, similar problem. Here we have to solve this by using that separation of variable. We will take y dy together, x dx together, and then integrate. That is, so now is the condition given there, that initial condition when x equal to 0, y equal to minus 2. Therefore, c is equal to 2. So this implies y square equal to y square by 2, x square by 2 plus 2. So y square minus x square equal to 4 is the answer. Okay. Now let us go for this sum, that number 20. In a bank, principal increases continuously at the rate of R%. If principal be P, then it is given that dp by dt, principal increases at the rate of R% per year. Then dp by dt is equal to R by 100, it's given. Isn't it? Principal increases at this rate, at the rate of R% per year. Find the value of R if 100 doubles itself in 10 years. Who will keep the money in this bank? I don't know. Log 2 equal to 0.6931. First to check whether we have written the equation correctly or not. dp by dt will be equal to R by 100 or Rp by 100. R is a fixed quantity. So it is rate of interest, no? Increasing at the rate of R%. So dp by dt will be Rp by 100. Now this implies R they have asked you to find. dp by p equal to R by 100 dt. R is a constant quantity and t is variable, p is also variable. So integrating, we get log p R by 100 into t plus c. Okay. It is given that it doubles itself when t equal to 0, let when t equal to 0, p equal to p0, say. So log of p0 will be equal to c. This implies log p mod RT by 100 plus log mod P0. Take mod P0 on left side. Okay. Now it is given that it doubles itself. For 100 it is 200. For P0 it will be 2P0. So when P equal to 2P0, T is given to be 10 years. So this implies log 2 equal to R into 10 by 100. So R is going to be, base is obviously, they have given the value of log 2 base 0.63, 0.6931. So there it will be 6.93%. R is equal to, okay. Go for sum number 22. In a culture, the bacteria count is 1 lakh. The number is increased by 10% in 2 hours. In how many hours will the count reach 2 lakhs? So this is not like radioactive decay, it is radioactive integration. Instead of disintegration, there will be integration here. It is increasing, no? Bacteria count 1 lakh, number increased by 10% in 2 hours. How many hours it will reach? 2 lakhs. Rate of growth is proportional to the number present. So P be the population. Let P be the population. Then it is given that dP by dt is proportional to P. So dP by dt equal to Kp. Okay. It is increased by 10% in 2 hours. I am using little bit definite integration concept. When you are integrating, only that initial condition will be assuming here, or you go by normal method. So again integrate, log P will be Kt plus C. Now when T equal to 0, P is equal to 1 lakh given. Okay. So log of 10 to the power 5 so from above log P is Kt plus log P minus log 10 to the power 5 is Kt equal to Kt. Okay. Now it is given that it is increased 10% in 2 hours. This is the condition you can use here, or you can write P is equal to 10 to the power 5 e to the power Kt. we need to know the value of k here, then we can simplify only. But you can use this condition, it is increased by 10% in 2 hours. So what I'm telling you, this you found okay, fine. But can I change it little bit here? See, if I'm doing it P0 to P dp by P k dt 0 to 2 hours. It's fine then. Only thing is that put P equal to 11 P0 by 10 because it is increased by 10%. So this thing is changed to log P. This will reduce your number of steps, I'm sure. 2 into k into 2. So log of P minus P0, you can write straightforward. Log P minus log P0 means log of P by P0 is 2k. P value you put, so from there you are getting k. K is equal to half log 1.1 base e. So once you get the value of k, you can substitute that directly, or again you can use the same equation. This is the actual exponential relation. Exponential growth is there in the population to understand that rate. How it is increasing, that you can do. You can plot graphs also. But here the question is, in what time it will be 2 lakhs? So I can use the same relation. Same relation is this one only, dp by p. Now again, dp by p is equal to k into dt, k into t. So this implies P0 to 2P0. P0 stands for 10 to the power 5 in 1 lakh. dp by p, this is going to be k into t. The time is we have to find the value of t. So log of p, the limit of integration P0 to 2P0, this time we need to find. T going to be log of, and k value you got earlier. So log 2 by half. So required time will be 2 log 2 by log 1.1. Keep your answer this one because log 2 log 1.1, if it is given, then only you can find. So this is about the sums from the chapter, that method of substitution, method of separation of variable to solve differential equation. One bit difficult sum I am choosing here, that on your textbook miscellaneous exercise sum number 14, that to solve the equation x plus 1 dy by dx 2 e to the power minus y minus 1. And here also the initial condition given, y equal to 0 when x equal to 0. So you write it this manner, dy by multiply by e to the power y for integration. This you need not do anything. Here if you take this one z, this is coming minus dz by z form. So answer will be minus log, isn't it? Even if you say that no, I'll put log k here, it doesn't matter. Integration constant, you can take c log c, k log k, whatever. Now this one, e to the power y dy by, what I did there, just I explain once more. I think all of you have understood. Put 2 minus e to the power y z. So this thing going to be minus dz by 2 minus e to the power y. We have taken z, so substitute. Now here we can write this as, all these will be on the same side, will be multiplied. K into mod x plus 1 into is equal to 0. No base is there means e base is there. So k into mod x plus 1. By writing equivalent algebraic expression e to the power 0, it's going to be 1. Now the value of k we can find. When x equal to 0, we have y equal to 0. So k into 1. So k is equal to 1 only. And now if we substitute there, we get the required solution. That mod x plus 1 equal to 1. This is the required answer. Okay.